Okay, so in this video I'm going to be explaining the basic differences between covalent and ionic bonds. So let's start with covalent bonds. We'll start out with drawing an oxygen loose dot structure. Oxygen has 6 valence electrons, and we'll draw 2 hydrogens. And hydrogen has 1 valence electron. So covalent bonds will happen when the electronegativities of both reacting elements are somewhat similar, not too far apart, which these are, and then also when both atoms reacting have valence shells that are that can be easily completed. So, for example, hydrogen has 1 valence electron in its valence shell. It only needs 1 more to complete it, which can be easily done. And then on the other hand, oxygen only needs 2. So in this case, a covalent bond will form. Both hydrogens will form a single bond with the oxygen, sharing one electron each. So these are completed, and oxygen is getting one from here, so it's completed right there. In this case, these are single bonds, sharing 1 pair of electrons each, and that's basically what a covalent bond is. And in this case, this is a weird particular case because oxygen has a somewhat larger electronegativity than hydrogen. Not enough that it would form an ionic bond, but enough that it would pull the electrons to its side for most of the time. So that would make this a polar covalent bond, making the oxygen negative, partially negative, and the hydrogens partially positive. So now let's move on to ionic bonds. So let's start with a basic example with sodium, which has 1 valence electron, and chlorine, which has 7 valence electrons. Draw a Lewis dot structure. So ionic bond will form when as opposed to a covalent bond when both atoms reacting have very, very different electronegativities. One is much larger than the other. In this case, chlorine's electronegativity is much larger than sodium's. And then 2, it's easier for an atom to lose or gain an electron to finish its valence shell than share. So in this case, sodium has 1 valence electron, and since this is not the 2 shell, it's the 8 capacity shell, it's much easier for sodium to lose its electron than gain 7 others. And then same thing with chlorine, it's easier to just gain 1 electron than lose 7 in terms of energy. So they prefer to just transfer that. So since chlorine's electronegativity, which is its ability to attract electrons for itself, is much greater than sodium's, what's going to do is when they bond, or when they meet, chlorine's going to take this, attract this electron towards itself, so that chlorine now, since it's gaining an electron, it has 8 in its valence shell, it's completed, but since it's gaining an electron, it's going to become a negative. And since sodium, again, completing its valence shell by losing an electron, but since it's losing an electron, it's going to become positive as such. And now, since they're both oppositely charged atoms, they're going to attract, forming the ionic bond itself. So one thing to be noted is usually covalent bonds are stronger than ionic bonds, but ionic bonds can also be stronger than covalent bonds in some certain cases. But usually, yeah, covalent bonds are stronger. And these are how each of these bonds are formed, and that's pretty much it.